Okay, irrational numbers. At some point in the ancient past, someone discovered that not all numbers are rational numbers. A builder, for instance, may have found that the diagonal of a square with unit sides are not 2 or even 3 over 2, but was something else. Or a garment maker might have observed that the ratio of the circumference to the diameter of a roll of cloth was a little bit more than 3, but still not a rational number. Such numbers are said to be irrational because they cannot be written as fractions. These numbers make up the set of irrational numbers. Irrational numbers cannot be expressed as a fraction of two integers. It is impossible to describe this set of numbers by a single rule except to say that a number is irrational if it is not rational. So we write this as shown. We would have the set saying that h such that h is not a rational number. Now for example number 3, we're differentiating rational and irrational numbers. We're going to determine whether each of the following numbers is rational or irrational. If it is rational, then determine whether it is a terminating or a repeating decimal. So for the first question, square root of 25. Well, the question is saying, okay, what do I have to square to get 25? Well, the answer is 5. So therefore, it is a rational number because it's a terminating decimal. If I use this on the calculator, if I put in the value, I'm going to find the square root of 25. Then you can see that it's a terminating decimal. And that terminating decimal 5 can be written as a fraction, meaning 5 over 1. Therefore, it's a rational number. If I take a look at the next example, I have 33 over 9. Well, 33 over 9 can be reduced to 11 over 3. Now, if we want to find that decimal, let's go ahead and do that here. I'm going to take 11, I'm going to divide it by 3 on my calculator, and you can see here that we get a repeating decimal, which is 0.66666666666. And here, they're rounding on the calculator to 7, but technically it's a repeating decimal. So 3.6 has a bar over it because it's repeating, therefore it's rational and a repeating decimal. So therefore it's a fraction that can be written as a repeating decimal. Now let's take a look at the square root of 11. Okay, we can see here that square root of 11, there isn't a number that we can square to get 11. So it cannot be simplified any further. But let's see what happens on the calculator. If I want to take the square root of 11, what I end up getting is a number that says 3.31662479. So this never terminates. This number can keep going and going and going and going, and it doesn't repeat. So therefore, because it doesn't terminate or it doesn't repeat, then we can say that it's an irrational number. If I take a look at the fraction 17 over 34, well, that reduces to 1/2, which gives us a terminating decimal of 0.5. So therefore, it is rational and a terminating decimal. Now, if we take a look at this last example, we have 0.303, 30333, 03333. Now, there's nothing in this that's terminating because the dots, the ellipsis, means it's continuing, and we don't see a repeating pattern. You know, the 3, but then it becomes 2 3s, and it becomes 3 3s, and 4 3s. So this is not a terminating decimal and not a repeating decimal. So it doesn't have a repeating pattern. So therefore, this is an irrational number.